Well, welcome. In this video, we're going to be looking at this letter E, and we're also going to be looking at natural logarithms. Now, actually, in this lesson, I'm going to break this video up into two parts. So in this first part of the video, all we're going to be focusing is on just that letter E and different uses for it. And then after that, then we're going to be focusing on natural logarithms. So we'll break this up into two videos focusing on each of those different parts. Now, to start out with, before we learn about this letter E, let's review the formula for the compound interest formula, which is if we want to find the total amount after a period of time, you'd start out by taking your principal, multiply that times 1 plus the ratio of your rate and your number of times it's going to be compounded. So you take your rate divided by the number of times it's compounded, and your exponent's going to be the number of times it's compounded times the number of years. Now, why is that significant? Well, this letter E, or anytime we look at that sequence, and if I were to put 1 in for your principal and 100% as your rate, that equation that's given for us here, 1 times 1 plus 1 over n to the nth power, that equation approaches the limit of E. And E is an irrational number, and we can figure out what that number exactly is on our calculators. So why don't you get out your calculators and we can look at how to figure that out. And then after we do that, we're going to go ahead and we're going to look at a use for that letter E with this formula for what we call PERT, which is your continuing compound interest formula. So we have our compound interest formula up above there, and then we're going to be looking at a situation when our interest compounds continuously. But let's look at your calculator to see how we can figure out our value for E and how to work with E, and then let's look at some different applications. Okay, so the way that we would find E on our calculator is if you look to the left of 1, we see that we have e to the x power. Now if I just click on that, actually I have to go to a calculator screen, but if we click on e to the x power, it'll automatically ask for an exponent. Now if I just want to see what the value for E is, I'm just going to put e to the first power and hit enter. And here's our first few digits of E. Now we're going to usually round it to the first maybe 5 numbers past the decimal, but we would say it's 2.71828. Okay, so let's look back at our notes. So again, here it is, it's 2.71828. Now what are some uses for E? Well, one of the uses for E is this, what I call PERT formula. It's the continuous compound interest formula, where if we're given an annual rate R and certain time T and our principal P, or initial amount, whatever that might be, we can use this formula. Now sometimes we're going to be asked to find the annual percentage yield. How do we do that? Well, the annual percentage yield is what are you gaining every year in interest. And to figure that out, if we don't know what it is, we would use $1 as your principal and 1 as your year, or 1 year as your time, and plug that in, and you're going to get an answer, and your answer is going to be in the form of a decimal. What we're going to do is we're going to change that answer to a percent, and then subtract it from 100%, because you're going to have an answer like 1.038, let's say. Well, if I change that to a percent, that'd be a 103.8%, which means you had 100% before. So this would be, again, like I said, 103.8%, which means you would have started out with 100%, but the annual percentage yield, what you're gaining on top of that every year, would be the 3.8%. So that's why you subtract it from 100. So let's look at an example. It says if $500 is put in a savings account at an 8% annual rate compounded continuously, we want to find the annual yield. So we know the annual rate is going to be 8%, but really in reality, what does that mean as far as what are we gaining for every dollar that we invest? What are we gaining on that every year? So again, in a situation like this, we don't care about the fact that we want to invest $500. I want to figure out for each $1 that I'm going to invest, how much am I going to gain off of that? So we're going to use our principal is going to be 1, and then it's going to be times E, so it would be 1E. So really that 1 doesn't really have any effect. And then your rate is 0.08 times your time, which is just 1. So we're going to just type in our calculator E to the 0.08 power. So when we do that, type in E, there we go, E to 0.08 power. So you get 1.0832 or 1.0833. Even if I just rounded it to here, 1.083, If I change that to a percent, it'd be 108.3%, but then we have to subtract that from 100 to get 8.3%. So we get 1.083, which would be 100.8 or 108.3%, which again you subtract it from 100, which means we have 8.3% annual yield. So that means if it's invested at 8% compounded continuously, what that means is that over the course of a year, you're really gaining 8.3%. Now, if we want to figure out how much you would have with that $500, how much you'd have after 1 year, this is where we're actually going to use that 500. So it'll be 500 times our equation, e to the 0.08 power. And whatever that is going to be your final answer. And if you do that on your calculator, I'll just tell you, you end up getting $541.64. Now you might think, well, you're never going to have a time where a bank's going to give you 8% compounded continuously. Well, the point of this is what this is going to do is this gives us a good estimation. Because if we were to compound it, even if it was compounded quarterly or monthly, it's going to be pretty close to $541 at the end of a year. Now let's look at this next example. I want you guys to try this one on your own. So I want you to figure out if you, first off, figure out what the annual yield would be if it was at a rate of 3.4% compounding continuously. And then figure out if you were to invest $1,000 compounded continuously, what would that amount be after 1 year? So why don't you pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, so let's see how you did here. In this first part, you should have taken and figured out, well, just the 3.4%. Remember, we'd have 1 as your P, 1 as your time. So we end up just taking e to the 0.034 power. That gives us 1.035, which as a percent is 103.5%, or our annual percentage yield, what we're gaining off that investment at the end of each year, would be 3.5%. So now if I want to figure out what would be the investment after 1 year, I would take 1,000 times that e to the 0.034 exponent. And when you do that, if you round to the nearest penny, you get $1,034.58. Now, in this next example, we are going to compare what it would be if it was compounded continuously and what investment would be if it was compounded quarterly. So you can see that this whole purpose of PERT is it just gives us a nice estimation to know what the value is going to be after a period of time. So if I have $500 that's going to be invested at 8%, and if it were compounded continuously for 4.5 years, let's figure out what that investment would end up being. So what you would do, again, is you would take your principal, $500, times E. Our rate is 0.08. Our time, so this time we have an exponent, is going to be 4.5. So if you type that in on your calculator, you're going to get an answer of $716.66. Now, let's say if it was compounded quarterly. So that's where we use that same formula that we had at the beginning of our notes for the compound interest formula. So we're going to take that $500 times 1 plus my rate, which is 0.08, divided by the number of times it's compounded. Compounding quarterly means that n is 4. Then our exponent's going to be 4 times the number of years, so 4.5. Whoops. And if you type that in your calculator, again, you got to make sure that you do this whole exponent, not just to the 4th power, to the 4 times 4.5. But if you do that in your calculator, you end up getting $714.12. So to figure out how much this compares, if I were to subtract these, compounding continuously is $2.54 more. So it's only about, over the course of 4 years, it's only about a difference of $2.50 compounding continuously, meaning compounding continuously means it's never stopped compounding, means the interest is continuously being broken up into small amounts, where compounding quarterly means that every 4 months, every 3 months, so 4 times a year, you're going to have that interest rate broken up. So you're going to get a little bit of interest being gained on top of the interest that you already earned. So the difference here is that it's only a difference of $2.50. So again, having this large formula here is a lot harder to remember than the simple formula of PERT. And PERT gives us a good estimation. Now let's look at the graph of e to the x power. That's going to be this one right here. So this is an exponential growth function, just like we've mentioned earlier. Exponential growth functions, so the domain is going to be all real numbers, because as x is increasing, y is also continuously to increase. But it continues to increase in both directions. So our domain is all real numbers. The range, as you look at this graph, it goes infinitely up, but as I follow this graph down, it gets really close to the x-axis, but it never really touches the x-axis. I know the graph kind of looks like it does, but it doesn't. So that means that we have an asymptote here of the x-axis, or the line y equals 0. So the range is going to be where y is greater than 0 then. Now the inverse of this. If I were to find the inverse, I would switch the x and the y around. So I would get x equals e to the y power. Now I don't want to leave it like that. I want to solve for y. So I would have the log base e. Because remember, if I need to solve this, I need to write this in logarithm form. So my base is going to be e. All logarithms equal exponents. My exponent is going to be was y, so it's going to equal y. And the value is going to be the same value that we have over here. So I've just put this in logarithm form. Log base e of x equals y. Now we call this log base e. That's a special kind of logarithm that we're going to talk about in the next video. We call that a natural log. So the natural log of x equals y would be the same thing as log base e of x. So with that, we're going to end this video talking about e, and we're going to transition now into the next video, which is going to be talking about the natural logarithms.